Okay, so good afternoon. We're going to work through our content on ecosystems. So the first thing is to understand what an ecosystem is. An ecosystem is really a combination of your biotic, so we're going to use this word biotic, which means living, and your abiotic. So it's a combination of these two things and how they interact. So this here is the same thing I'm saying here. I'm just summarizing it. So one thing to understand is that we all live somewhere. This somewhere is called a habitat. In other words, where we live, how we interact with it is what's going to make our ecosystem. So an ecosystem has a flow chart. Um, Now I'm gonna skip to the flow chart, and here we go. So if you're looking at an ecosystem, it starts off with a organism, um, and your organisms live somewhere. They live in this habitat. The other word here would be a biome. A biome is an area that has many ecosystems. So a tundra would be a cold ecosystem, but that would include all the areas of it. The ocean is a biome. There's not just one part of the ocean. There's the top part, there's the bottom and middle part, and they all have their unique environments. The forest is another ecosystem. And once again, we're talking about multiple things within this one area that will affect how an organism or a species is able to survive. Within our ecosystems, we can have a single organism. So a single organism is living there, in this case, an antelope. Now, if you have a bunch of antelopes, you now have a population. So organisms combine to form populations. Populations combine to form a community. So in this case here, all these different species make up this one community. They live together, they may compete, they may interact. However, once you combine all of these living things and you combine the air, the soil, the the water, you're now forming an ecosystem. You're combining the living and the non-living. So a organism combines to form a population. Populations combine to form communities, and communities, when you add the non-living factors, will give you your ecosystem. So here's a quick recap. So biotic means living, abiotic means non-living. So here are the main ones. So we have here animals, people, bugs, bacteria. Anything that can either make its own food or has to consume something will be biotic. And the word abiotic doesn't mean dead. It means non-living, was never living. A rock, sand, soil, water, air, wind. These things are not dead. They were never living. So do not confuse the term living or biotic with dead. Abiotic with dead. Within our ecosystems, the energy has to move. And by energy in this lesson, we're talking about food. So um, all living things have to consume something. Okay. Um, except for producers. They make their own food. And once they make their food, that enters our food chain. So any animal that can make its own food, we sometimes use the word producer. We will actually also introduce the term autotroph, which also means self-feeding. So these two words mean the same thing. The word consumer we replace with the word heterotroph. And that simply means different feeding. So you have your animals or your plants that can make their own food, and something must eat them. In any food chain, the arrow shows where the energy is going to. So the energy that the plant made through photosynthesis is then transferred to the caterpillar when it eats the plant. The caterpillar is eaten by the frog, and some energy goes to him. The frog is eaten by the egret, and it goes to him or her. So the energy is moving as your different consumers go through. So here's that in a nice summarized version right there. The role of your producer or your autotroph is to make food. And you can pause and look in here, but there are two basic processes that allow these organisms to make their food. Either it'll be photosynthesis or chemosynthesis. And this is what occurs at the bottom of the ocean where there is no sunlight. But so where those bacteria feed that food chain. Then we have our consumer or a heterotroph. Once again, this is anything that eats something else. There is one other category called a decomposer or detritivore, pardon me, which is the other type. These are also heterotrophs, but they specialize on eating dead or decaying things. So they break things down. So you have to be a decomposer or detritivore. But either way, their job is pretty much the same. They're breaking things down and allowing that energy to be recycled to the food. So in any food chain, we're going to start with the ultimate source of energy here being the sun, unless it's the bottom of the ocean. Energy from the sun through photosynthesis is transferred to the plant. The plant is then consumed by a bug. The bug is then consumed by a fish. The fish dies and is broken down by the mushroom, and that will release some energy back into the soil, which allows this producer to do his job again, and the cycle will start. When we're looking at our food chains, we're saying that one thing to recognize is that as you move up a food chain, only 10% of the energy flows up. And so every trophic level, 90% is lost. So down here we have 100% of the energy because these guys make their own food. Up here we're going to have 10%. Up here we're going to have 1%. And down here it'll be 0.1%. And so every level, only 10% moves off, or 90% is lost either as body heat or simply to support life functions. Breathing, pooping, making babies, all those things require energy. And so all food chains will start with a producer and end with a consumer. But understand, once this guy here dies off, this bear dies, he will then be broken down by a decomposer, and that decomposer will put his nutrients back into the soil, which allows the plants to go ahead and grow again. So once again, the cycle moves on. So within these roles, there's a certain word called a niche. A niche simply means the job you do. And so, are you a producer? Are you a consumer? It simply means job. Now, multiple things do the same jobs, but they don't do it in the same way. A bacteria and a fungi both decompose things. They do it differently. They actually can live in different areas. A wolf and a lion are both carnivores and predators, but they feed in different ways. So nature will say you can have the same job, you just can't do it in the same way. So, and that leads us to this thing called the competitive exclusion principle. So what we're saying here, if you have any two animals, if they want the same thing and they live in the same area, they're going to compete. The only way you can find different things or the same type of animal in the same ecosystem is if they are feeding on different things or they have different jobs. If you have two birds and they want the same thing, they're not going to get along. They're going to fight. And therefore, natural selection would kick in and say, hey, survival of the fittest. Only one can survive and go on and do that. So now that we understand that, we're going to go to interactions. We're going to go to relationships. There are some basic relationships to understand. The easiest one is a predator and a prey relationship. This one eats this one, that one gets eaten. That's their relationship. The other one is competition. This is where if we want the same thing, we're going to fight for it. Cooperation, we're going to work together. Like wolves hunt together. Killer whales hunt together. Dolphins hunt together. So they cooperate. Coexistence is generally where two animals live in the same area, but they don't want the same thing. So that they don't affect one another. So in other words, a lion and a cheetah both live on the African savanna, but they eat different foods, so they tend to get along. A lion, however, will not let another lion come into his territory because they won't coexist. They would compete. And anytime you compete, one will live and one will die off through natural. The next interaction is something called symbiosis. And this word here simply means relationship. So there are three basic symbiosis relationship uh, symbiotic relationships. One will be mutualism. This is where they both benefit. So it'll be a plus plus. The key example here will be a bee and a flower. The bee gets nectar from the flower, but the flower allows some of the pollen to get on the bee's legs, and they can have sexual reproduction. So they both need each other. The flowers would die without the bee, and the bee would die with the flowers. Then we have commensalism, where one gets something good, the other one gets nothing. Here's a whale and here's a barnacle on the whale. This barnacle gets a free ride, it gets food, it gets the save energy, it gets shelter, but the whale is so big, the barnacles don't affect it. So one gets something good, other one gets nothing. And then we have parasitism, where one gets something good and the other one gets a negative. So the tick bites the dog can get sick, the dog can get hurt, but the tick gets good stuff, it gets food, it gets shelter. So that would be a parasitic relationship. Positive, 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 nothing, and negative, positive. So here's the cheat codes for these three symbiotic relationships. So if we're looking at population, the one thing to understand is that there are different things that can affect the population. Some of these are density dependent and some of these density independent. Density dependent factors, these are affected more when the population goes up. So for instance, crime or even disease are density dependent. So the more people you have in a certain area, the higher crime tends to be. Density independent will be a natural disaster, a hurricane, a storm, a forest fire, disaster. Okay, does not care if it destroys a small town or a big city. So these will affect population sizes regardless of how big or small your population is. So if your population is being affected, we're going to say that you now have a limiting factor. A limiting factor will always be an abiotic. And here are the main ones. Food, water, shelter, and space. So if any one of these four things is in short supply, you're going to find that your population will go down. If these are in abundance, they will go up. And you will know if you're running out because you will hit your carrying capacity, which is the maximum of a population that will sustain. Anytime your population gets too big, nature will say, hey, you can run out of food, water, shelter, or space, and that will bring your population back down towards your carrying capacity so that you won't run out of resources. So when you're looking at your different connections, whether it's predator and prey, competition, commensalism, mutualism, is that everything is connected. And in ecosystems, everything matters because it's an interaction between how the animals interact with one another and also how they're affecting the environment. And so in this example here, wolves and a moose, this is the predator-prey relationship. The wolves eat the moose. But however, what you'll see here is as the moose population goes up, there the one generation afterwards, the wolf population goes up. But if there are too many wolves, so this wolf is a wolf spike here. So now there's so many wolves, they eat off all of your moose, and as the moose population goes down, you'll notice the wolf population will go down. So everything needs each other. The moose need the wolf to hunt and kill the weak and the diseased member of their herd, but also the wolves need the moose for food. Also, if there are too many moose, they're going to kill off all the grasslands, and that'll affect everything. So remember, the ecosystem, it is a combination of all the living and the non-living things, and everything matters. All right, so that's your 3 weeks review. You also have some questions on Google Classroom to complete after you finish this Ed puzzle. So I hope it helped you guys.